And now I pass the stage to you, Joseph.
Okay, so yeah, hello, and thank you for inviting me to give this seminar. As Changi said, I'm Joseph. I work at Bristol in the cybersecurity group. Oh God, now what's going on? So this talk I'm going to give, can people see a warning about this meeting being recorded on Zoom? Hang on, I'm just going to get rid of it because it's quite annoying in my way. There we go. Let's try this again. So this talk I'm going to give is about this paper I presented at ICSE this year. Do this, do that, and nothing will happen. And it's joint work with my colleagues, Nick, Ben, and Avais, all at Bristol. If you saw the talk at ICSE, great. This is going to be a bit of a repeat, but I have more time, so more details. Hopefully you'll get some more out of it. If you didn't, also great. You can see it here. So this is a talk about passwords. And passwords are important. Hopefully I don't have to say this, it's a security privacy seminar, but they're the way we normally check users are who they say they are. We check they know this secret password, but passwords get stolen. So we hash them, we hide what their value is with something slow and key, so you can't make a lot of guesses really quickly and try and crack them. And we add salt so you can't see when two users have the same password. And we make everything big enough and long enough that even if you are just going around guessing, an exhaustive search is going to take you forever. And developers seem to really struggle with password storage. Conceptually, it's fairly simple, but there's a load of little gotchas and people get caught out. And if you kind of want some evidence for that claim, there's wonderful sites like haveibeenpwned.com. So this is a website run by Troy Hunt and the 1Password people, if I remember correctly. And basically what they do is they collect big lists of passwords which have been breached. And if you want to know if your password has been involved with a breach, they'll let you know. There's an RSS feed you can subscribe to, and you find a load of them being pinged all the time. Another two got added. And it's not just tiny companies who lose passwords, it's everyone, right? It's everyone from the smallest companies to big, huge corporate monoliths like Facebook and Audi and University of California. You all find them suffering password breaches. And if you go and look at exactly what gets released, it's kind of worrying. In 2012 and 2015, we're seeing plain text passwords being leaked. It's passwords stored with no protection on them. In 2016, 2020, okay, it's hashes, but they're MD5 hashes, which is not an appropriate way to hash a password. They can be cheaply cracked. This isn't how you're meant to do it. And if you want kind of more academic source for this claim, there's a bunch of work by Nakashina and the folks at Bonn, where they've showed repeatedly now that developers do not store passwords right. They only do it securely if you explicitly ask, and even then they don't make that good a job of it. This is kind of really worrying, and it's something that developers seem to really and continuously struggle with. Okay, so that's one side of it. It's the other side. Well, specification. And specification is good. We know that making a plan, however formal or informal, is a good thing, right? You get better code if you make a plan before you start trying to write it. And you don't just have to take my word for that. We've got Turing Award winners, people like Fred Brooks telling us, careful function definition, careful specification, and the disciplined exorcism of frills of function and flights of technique all reduce the number of system bugs to be found. We've got industry experts, people like Joel Spolsky, one of the people responsible for Stack Overflow and the Y Combinator, saying, if you don't have a spec, you will always spend more time and create lower quality code. And this is all alongside decades of research into specification techniques, into formal methods, into how people write code. A spec, any form of spec, is pretty much always a good thing. So, on one hand, we have a task where developers routinely produce poor quality code. On the other hand, we have a technique that improves code quality. So, okay, does the act of writing a spec for a piece of security-sensitive code lead to developers producing more secure code? In other words, can we trick developers into programming securely if we try and get them to write a spec first? And for those of you who kind of want to switch off now, the answer is going to be kinda. Yes, we can show a significant, albeit very, very small, positive effect. This is great from my point of view. Woohoo, I can write a paper. But more importantly, developers seem to think that they're already storing them correctly to begin with. That they know password storage is tricky, but they've got this. They know what they're doing. And that's, to me, is kind of interesting and kind of worrying. And perhaps I shouldn't be focusing on ways I should be trying to trick developers into programming securely. Perhaps this isn't the problem I should really be focusing on. Okay, so that's what we want to show. How are we going to show this? Well, basically, this paper is about a 2 groups experiment. We'll get both groups to write some code to implement password storage. One group will write a spec, any form of spec they like before coding. The other group can get straight to it. We'll score the implementations, we'll ask for some details afterwards so we can do some kind of qualitative analysis on their rationales and reasoning. That's basically the approach we're going to take. So specifically for this experiment, we're talking about 138 people who are all self-describing as developers. 61 in the spec group, all could write whatever kind of spec they wanted. If you're hoping for, latest abuse cases or latest specification techniques, pretty much all of them just wrote a high-level pseudocode plan-like description. Some people who weren't primed to write a spec decided to write a spec anyway, and we scored all these solutions with something called Nakashina's criteria. And so what's that criteria? Well, it boils down to how you're meant to store a password. As I said, it's a load of horrible gotchas and horrible little cryptographic details to go away and remembered. Luckily, you don't have to keep them all in your head. Standards exist. You can go and look them up, read them. This one is NIST 863B, and it tells you how to manage digital identities. Other standards exist. And if you open it up and you go to section 5.1.1.2, you'll find several pages and paragraphs of text telling you in great detail exactly what you shall, you should, you must do, which algorithms to use and how to configure them. Verifiers shall store memorized secrets in a form that is resistant to offline attacks. Memorized secrets shall be salted and hashed using a suitable one-way key derivation function. Key derivation functions take, and so on. It's fairly dry text, but it tells you exactly what you need to do and why. And as you get further into it, it starts going into the details about how you should configure specific algorithms. What Nakashina and co did is they took the standard and they converted its recommendations into a metric. It's a score between 0 and 7. If you get a score of 6 or more, you're following industry best practice. You get a point for salting, a point for hashing. You get a point for making sure the hash is of an appropriate length. You get a point for using an appropriate key stretching work factor into the hashing algorithm. You get a point for using an appropriate memory hard hashing algorithm. You get a point for generating a salt randomly, and you get a point for having a really long salt. It's all sensible things. You see this metric quoted sometimes at the end of articles online telling you how to store passwords as a kind of do this. It's kind of what you're meant to do. Okay, so that's the experiment. That's how we're going to score it. What do we find? Well, here are the scores from the paper between each of the different groups we considered. We've got the spec and non-spec groups. Those prompted for a spec, those who said they wrote one anyway after the task. Over half of them, in fact. So even if we're not prompting people to spec, from what we saw, over half of people will make some form of plan before coding anyway. We've got those who weren't prompted, those who weren't asked and didn't claim to write a spec. We also asked if people went and referred to a standard, about a quarter did. But instead of looking at a standard, they all seem to just look at blog posts or API documentation. We also asked if people had experience or formal qualifications, and I'm beating around the bush here. How did people do? Well, pretty universally badly. 65% of people just stored their passwords as plain text. 92%, they remembered to hash it and do something else. But that's really low, right? Just 2 people got to best practice according to Nakashina's metric. And as depressing as that is, that's kind of what we'd expect, right? This is in line with what Nakashina and others have observed whenever they've done similar experiments, right? Developers seem to really struggle with password storage. But, we've got numbers. So if you go and do a comparison between groups, yeah, there's a significant difference between the prompted and unprompted groups. Tiny effect size, but the scores are higher on average in the prompted group, just over 1 compared to just under a half. So yeah, if you explicitly prompt a developer, they might remember to hash a password instead of storing it in plain text, but that's about it. So does spec writing help password storage? Well, kinda. Yes, technically, an effect is there, but it's not solving this problem that developers still seem to really struggle with this task. We're not suddenly going to get every developer implementing password storage correctly just if we ask them to write a spec beforehand. You just might remember the smallest detail of it. And if you actually look at what the developers did, it kind of gets worse than that, right? You know, everyone who scored a point got it from hashing the password, and you remembered something else if you got anything more, like usually salting it. But if you go and look at the choice of hashes developers were using, they're kind of bananas, right? People hashing with MD5 or making up their own ciphers, a substitution in this case. Just 11 people used a proper memory hard hashing algorithm, things like bcrypt, pbkdf, or argon2. You know, there's people using base 64. It's not even a hashing algorithm. It's depressing. But again, people using these secure hashing algorithms, even that wasn't perfect. There are people who would recommend using bcrypt and MD5 in the same sentence as an acceptable alternative. And again, I think this just emphasizes further, this is a task developers really struggle with. They struggle to know the difference between a password storage hashing algorithm and a regular hashing algorithm and any general ciphers. And what do developers do when they struggle with a task? Well, they Google for it. And we're deeply suspicious folks, so all the implementations we got, we stuck them into Google. We went and had a look and seen if they'd been copied from online. And yeah, developers really do seem to copy from Stack Overflow. And this isn't a bad thing, right? If you actually go and look at the scores of the developers who seem to copy from Stack Overflow, they did statistically better than those who didn't. Again, we're talking about the difference here being a score of just over 1 compared to, well, about a half. But again, copy from the web, you might remember to hash the password. And in a way, that's not surprising, right? There's loads of really good resources out there, like this one from OWASP, but no one seemed to copy from this one. I just like it. It tells you clearly, straight away, how to do it, and in a way that will score you lots of points, according to Nakashina's metric. So why aren't people scoring higher who are copying, right? If there are good solutions out there. And kind of one common thing we saw when we're going through these articles is they often tend to follow kind of a pattern. You start with a simple version of it and explain why it's bad and attempt to build at the bottom. So this first version of this article starts with, oh, just store the passwords unencrypted. And by the end of the article, there's a section on how to do it properly that would score highly. What we'd find is that people would copy the first thing that worked, which if it was a counterexample, would be that. They wouldn't read the whole article or they'd skim sections of it. We saw this with several of these Google examples. Bottom, if they got there, have scored them full marks. What got copied at the top was the counterexample. And a kind of nice example of this is this one. This developer was a bit cheeky, in my opinion. In the study, their implementation basically consisted of that second paragraph. Not ideal, but vaguely pseudocode. What they essentially wrote is the first way to store passwords in your database is plain text. There are a couple of advantages to this. They aren't really advantages at all. The first is that this makes it incredibly easy to verify the user's password during login. The second is that it means that the user never forgets their password, so we can email it to them. And what's kind of interesting with this one is the very next sentence, the very next few words in this article say, don't do this. I can't emphasize strongly enough that you should never, ever store passwords in plain bit text. Yes, that's the bit they were copying as their kind of implementation of how to do it. And I think there's just a bit of a general warning here. If we want to write blog posts telling developers how to do things, I think that's great. But we need to be a little bit careful. We need to make it explicitly clear which bits we want developers to copy. Because I don't think we can guarantee that developers will read our articles in enough detail, or even to understand the whole thing, right? Don't lead with counterexamples because someone will copy it. Anyway, so far, so depressing. Why are developers doing this? Well, simple way to do that is just to go and ask them. And this is where I think actually in this study, we start to find something actually interesting. We asked each of the developers when they were doing their task if they had thought about any threats when they were doing their implementation and why they did what they did. And then we used a qualitative grounded theory-esque coding approach to pull out reasons and themes from within their explanations. So here are the threats developers said they'd considered. Threats from unauthorized access to the database, threats on attacks on passwords, cracking rainbow tables, threats from threat actors, threats from vulnerabilities in their code. They had about concerns about making passwords harder to see, or the threat from malware, keyloggers, and attacks. Concerns about the wider impact of an insecurely stored password, and threats from insiders who might have had access to these stored passwords. And the kind of thing to say here is this is all completely reasonable. This is what we hope developers are considering, right? They know there's a security context, and they are aware that, we need to make sure these things are protected from unauthorized access and they are resistant to cracking. And there's kind of this other interesting threat some developers identified, we called reflection. Some developers expressed in their threats they were concerned they might not have done a poor implementation of this, that it might not actually be secure, that they knew this task was hard. So, for example, in the case of these two, but their implementations both stored the password directly. Yet they were clearly aware that perhaps they should have done a bit more than that. One of them said, "Unfortunately, I have not considered any threats, but I know the password should be encrypted. Actually, I didn't consider them in the pseudocode, but I assume that there are some threats like root hacking." And again, several of the developers knew how to store a password even if they didn't. So this developer, again, stored the password in plain text. But when considering the threats, they were saying, well, the best security practice is not to store the password at all, not even encrypted, but to store the salted hash with a unique salt per password of the encrypted password. Actually, they're getting the basics of it right there. They've done their implementation just storing it as plain text, but they clearly know what they should be doing, and it's frustrating. And again, this is similar result to what others such as Nakashino have shown, right? Developers, unless you ask them to do it explicitly, securely, as a general rule, don't. And it's, as a security engineer's point of view, it's frustrating. Some recognize after the task that they forgot little bits of it, and this is nice. If you give people time, they do start to think about these things. Thinking about it, it might have been a good idea to concatenate some constant text at the end of the password, so that whether the user uses the same password on two different attack services cannot be determined by simply checking whether the hashes are identical. They've realized they've forgotten to salt the password. Developers are aware of how to do this task correctly, or at least some of them are. If we look at why people wrote the code they did, we ended up with this long codebook. And okay, the most common reason, again, most developers' responses required more than one code, was the most common code we saw was that it made the implementation easy, that it was an easy way to complete the task we set. Okay, well, we're setting a task in an online survey. That's completely reasonable. Try and get it done as quickly as possible. And again, as with the threats, there are a bunch of codes that describe when developers recognized their implementation wasn't great. That it was naive because I don't know how to write the code. I just used a literal approach. That they acknowledged its limitations. It assures the storage of the password even if the security is not high, or it was the only way they knew how to solve that problem. So, for example, one developer said, "I wrote the code that way since it's the only way I know how to check the passwords are valid and the hashing storing bit, because unhashed passwords are unsafe." They recognize that there is a need to hash. Right? Other methods could be used to encrypt the password, but I've heard that hashing or MD5 hashing is the most common. Okay, they know about hashing. There's a little bit of confusion about what different hashes are for, but they have heard of some of this, and they think they're getting it right. They know you should hash. It was the simplest and easiest way I could think. This way it protects most cases, but of course, a more elaborate with more defense lines is needed, and the SALT implementation is not very well done. Okay, this developer has done it the easy way to do it, but they're aware there's limitations to it. They're aware that SALT implementation could be better. Actually, this person scored 4, so they're in the top 10% of the respondents for this study. They've actually done a relatively good job. A really interesting one I really like is this one. So this developer has gone and asked his friend who knows about cybersecurity, and they've told him to do this, and they've scored 1 point from hashing the password, again with MD5. It's not great, but at least it's something. And they're aware that this is a cybersecurity task. You can also spot other things in the various justifications. So one of the feature justifications, they've justified their code as, or given the reason they wrote the code in the way they did as, look, this gives you a nice feature. And this one's kind of interesting because the person who copied the blog post from earlier has said, well, look, this is a simple way to code and it allows for reminders to the recipient, which is what the text they copied from does tell them. So they have clearly read and interacted with that text at least a little bit online. They just haven't gone further into the please don't do this or to the bottom of the article. For me, though, the most interesting codes here are the readability, experience, past effort, best practice, and consideration of threats, because they kind of represent developers saying, I got it right. So, readability, I wrote the code that way because it shows the idea very clearly. Experience, I'm somewhat experienced in applied security. Replication of previous efforts, it's something I've done before. Perceived best practice, this is the most acceptable way of storing passwords. Consideration of threats, storing passwords in plain text is a huge security concern. So for example, one said, I've been working as a software engineer for 8 years and have developed authentication systems for our clients hundreds of times. So I've come to learn the best practices for doing so. They're a professional developer. They've been doing this for years. They clearly think they're following best practice, but they're falling short. And it's interesting that they think they're getting it right. This was kind of really common, right? I've done this before. I wrote a user registration system in the past, and they just get the basics, right? Hashing and salting. I'm used to implementing similar login and authentication mechanisms in university projects. And the thought process is always the same. And they score 0, which means they're just storing the password in plain text. And yet they're doing this in their courses and they think this is the right way to do it. This one I really like. I wrote the code like this because it's something I've done before. I've written a login system for a password manager, so recognize that passwords before storage should always be hashed and encrypted to avoid storing them in plain text. This is a task they've done before. It's something they're doing explicitly in a task to store passwords, and their implementation gets the bare basics. If you count cryptography algorithm to hash the password, preferably using as a salt, as yes, please definitely use salts for these things. And, I, as a security person, we know not to roll our own crypto, right? We don't try and reinvent cryptography algorithms. Why are we trying to roll our own authentication as well? This is maybe something that we should be considering in the same terms as crypto. It's tricky to get right. There are lots of little nasty gotchas. You should try and avoid doing it if you can. And there is no reason to do this. Several languages have password hashing built into their language, right? If you go into the latest versions of PHP, there is a hash password method that uses bcrypt and by and large gets it right. There are usable libraries like libsodium that tell you how to do password storage explicitly, give you task-focused APIs and examples. There's things like OpenSL, which have a password function for it. Okay, by modern standards, it is not secure by default. Maybe we shouldn't really mention it, but it's there. Why aren't developers just using the APIs given to them? Why are they rolling their own and getting it wrong? And maybe this isn't their fault, right? There's this lovely quote by Harry Truman on what it's like to be the American president. And he says, he'll sit there and he'll say, do this, do that, and nothing will happen. And perhaps we're seeing the same thing with this kind of security tasks and looking at developers doing password storage. It's not enough for us to sit around pointing at our standards, pointing at our usable APIs and saying, well, just use that, use this, read the standard, because developers are still struggling. They're not using these usable APIs, they're rolling their own again and again, and they're getting it wrong and it's leading to password breaches. And maybe I'm just as bad for this, right? I started this paper looking for a way to trick developers into getting password storage right. And that's not the right approach. It's not right to blame and bemoan developers for not reading standards and not using the right API. We need to find ways to actually work for them. We need to get them using the usable APIs, not reinventing stuff or sulking when they get it wrong. So if I'm saying we need new approaches than just trying to get developers to read and understand the standards, what might they be? Well, one approach is we could try and push developers away from doing it themselves. Instead, pushing them towards frameworks which do it for them as part of their app. Things like Django here, which has a wonderful password management system in that goes and explicitly references NIST 853 and does what it says. baked into the thing, baked into the languages like PHP, which just do it for them and do it right. Related to that, we've got federated identity standards, things like OAuth, that developers can just use and get on with making their apps and not have to worry about doing the authentication. Though it would be remiss of me not to mention this isn't a perfect solution, right? Leaving aside privacy concerns with these things, the big providers of OAuth are Google and Facebook, who obviously have a vested interest in what sites people are viewing. Configuring these systems themselves is not trivial. We don't want to switch one set of gotchas hidden in a standard for another set of guidance. Something that really interests me here is these AI-based coding tools. Things like Copilot, just come out for GitHub, essentially act as Clippy for programmers. I can see you're trying to implement password storage. Do you want me to do that for you? Given these tools are taking data from Stack Overflow, taking these data from GitHub, I'd be really interested in seeing what they suggest, whether it's actually secure and whether we can kind of use these approaches for nudging. And I'd be really interested in hearing anyone working in that area. But anyway, that's our paper. Developers struggle with password storage. Specs help, but they're not going to solve the problem of poorly stored passwords. We need to work with developers and help them. And I have gone far too fast, but that's it from me. Any questions?
Yeah, let's, if you have any questions, please ask. Either in the chat or ask directly.
Well, Chung Yu, this is Roy here. Well, that was a big mistake for you to invite people like me to ask questions, Roy. But before I ask the question, I want to compliment Joe. What an amazingly good study this was.
Thank you.
Chung Yu announced this, maybe a week ago. I can't remember. And I read the abstract and I thought, finally, somebody is asking a sensible question, right? So this is just lovely, But so I guess I have a comment and then a question. So my comment is, could it be, I guess I'm framing this as a question, but it's really a comment. Could it be that the problem you've encountered is not a technical problem at all? It's a social problem, right? In which case it's sort of unclear what to do. Yeah, I don't know. Maybe it's a social problem. And the other thing that I would say is it's when I read your abstract, I thought, well, okay. So here's somebody who's trying to figure out what it is that's going wrong. And he has a hypothesis that it's about writing a spec. And either this pans out or it doesn't, which is just the kind of study that I like to see, is very clear cut. Okay, all right, so it didn't, right? And so my approach then, if I had done this, would be to say, well, all right, so we've asked a question about what could be the problem, and apparently this is not the problem. So then we must, I guess we're going to have to ask some other question to try to get to the heart of the problem. And so maybe my question here, which is now somewhat muddled, maybe I should just ask you if you could speak to what I've just said.
So is it a social problem? I think it's a little bit of both, right? There's issues with development that people don't always copy the thing you want to, and they don't always remember all the wonderful cryptography lectures they did at university where we went and taught them, no, this is how you do password hashing, right? And there's an issue with, people copying it. Actually, for larger companies, you kind of hope the traditional code review process would tackle this, right? If you're following that thing there, you can have your boss come along or someone come along who's a bit more experienced and say, no, actually, no, this is tricky. We need to make sure we get this right. Let's get an expert in here. I think this problem really starts to become pronounced when you start to have development teams where it's essentially one person coding away in their bedroom, trying to make the next hot app. And there aren't always necessarily the same checks and balances that traditional development has got that help, catch these problems ahead of time. I think, in that sort of sense, actually these AI tools, maybe they start to be helpful, because I don't think they're going to get a full cryptography implementation, just written off by a strange magical tool, or I hope not as a programmer, right? Otherwise that's me out of a job. But actually spotting, hey, you seem to be doing password hashing, you're using MD5. Maybe do you want to not do that? These sorts of nudging approaches, I think there may be some scope there for helping those. Inside larger organizations, yes, it's a social issue. Yeah, as opposed to other approaches for solving these things, yes, I mean, specification helps a little bit, right? And again, for this study, we showed that when you just ask people to do a spec, that doesn't really help, or you just remember to hash. But whether specific techniques within specification, all our developers were essentially just allowed to go away and make a plan, just stop and think before they start and implement.
Do you know whether or not your participants did any testing of their code?
I don't, and I don't know how long they spent on each one either. I suspect not a lot. We paid them a reasonable rate. We sort of worked out what a graduate salary was, and said it's going to take about 20 minutes, so that's an appropriate thing. But again, Schneier's point with other studies in this thing, you pay peanuts, you get peanuts. To an extent applies here, right? We're doing an online study. What's interesting to me, though, is the responses why they did this, because some of them, quite a lot of them, seem to indicate they thought they got it right. And I don't think you'd see that if you had people going, well, I'm just sticking any old thing in just to get it done, and I don't know how to do it. That for me is the interesting thing here. People think right, and they're simplifying.
I would wonder, well, let's see, so in the dependability world, which I'm kind of a part of, we tend to ask to do a hazard analysis, right? To think about, well, what could go wrong here? And there are some fairly simple methods of doing hazard analysis. What do you think would happen if you asked your participants to do that before they pound the keys to type out the code?
So so we did that kind of the other way around. We went and asked them, well, did you think about any threats afterwards? And afterwards, they were thinking about the right things. Now, whether you'd get the priming effects from it beforehand, maybe. I think there's still an issue here. So one of Nakashina's studies is, they explicitly try asking them, no, please do it securely, and think about what that means and do it securely. And then developers do a bit better. They do remember to hash occasionally, but they're still not doing a great job of it. It's still, they might remember to use any old hashing algorithm and maybe add a sultan. So it doesn't, I suspect you get a similar effect to that.
Yeah, I did a study, I don't know, 20 years ago, maybe, in a class I taught. And loosely speaking, the assignment was, I'm going to give you a file with numbers in it, and your task is to write a program that adds up the numbers and computes the mean and standard deviation. Simple. Okay. There were 23 people in the class. Only one person got it right.
Yeah, I'm not surprised.
But something is just not right here.
Yeah.
Right? I mean, I don't know what it is.
Yeah, and I think going and saying to people, how can we get this right? It's not the right approach to solving this. We need to find a way that works for people to help get it right, rather than just saying, look, why aren't you just going and looking at the standard? Why did you not loop over all the people in the study. Why did you calculate the mean wrong? We need to find a way that helps them complete this task, rather than just going, look, people aren't getting this task right. Any more?
Well, it's all depressing, but I still think you have a lovely, lovely study there. I really appreciate that you did this. It should stand as a beacon of light to other researchers to do similar things and to probe maybe deeper with the kind of thing that you did.
I hope so. I'd really nice if we could stop having password breaches every other week.
Well, it's not just about passwords, right? It's about other phenomena in coding.
Yeah.
Okay, we have a few questions in the chat. The first one is from Jeremy. Jeremy, do you want to ask the questions?
I can see the question online on the chat, and it says, "Did you?"
Right.
Here you are, Jeremy. There we go.
And I stopped my video. Okay, started my video. Hi, thanks for a great talk. Did you record educational achievements by your developers? So I'm interested to know whether the stuff we're teaching our cybersecurity MSCs and to odd modules to undergraduates has made a difference.
So we did record level of education attained and also level of experience. It was weakly correlated with score. Again, unfortunately, you're dealing with this with a score where 92% of people are getting 0 to 2.
Yeah.
Yes, education does seem to have a help, but it doesn't deal with the fact that people are only getting the absolute basics right to begin with. So yay us, but also we need to do better or find some other way of dealing with this, because it's not solving the problem.
Okay, thank you.
Right, so the next question is from David. David, do you want to ask your question?
Hi, yes. My question was about the software audits, because if it's not it's not supposed that software is going to be audited for critical purposes. I mean, the programmers can do whatever they want, but suppose the team leader is supposed to check what they're doing, the implementations, and define good practices. I don't know if you could.
Yeah, so absolutely. We would hope code review processes, we would hope development processes in a large organization would help prevent this. And where you've got traditional coding styles, development life cycles, yeah, you'd hope that would normally catch these things. The problem we have is that these these software life cycles aren't always necessarily applicable to all modern developers, right? There's an awful lot of people who have learned to program in school and are trying to program on their own in their own house, build an app or a game where it's just one developer. They're, for me, the really interesting people here, because as you say, software audit, we would hope would catch this. That's how organizations like Facebook, where they're having breaches and they're losing things, companies like Audi, where you'd kind of hope there's more traditional engineering life cycles in there, are still having breaches. Is still worrying. These suggest these things aren't always being catched, but yes, you would. But it doesn't solve that problem where you've just got one developer working in their own. And they're an increasingly large and normal way people are writing code. We can't assume you're in a software house where you're going to go through a code review process. Wish we could. Open source sometimes helps these things, but many eyes still requires many eyes to do the audits, and not all software gets it.
I see. Well, thank you very much.
Right, so the next one is Percy. Percy, do you want to ask your question?
I can see the question.
Hello. Actually, it's not a question. I just want to mention something because I am coming from engineering background. I was able to see many things in companies, I think the big gap in this situation, I mean, why developers don't put into practice these security measures is because they don't have the culture. I mean, the company, for the company, first of all, is not that important. Security is not that important. Secure coding is not that important. So they don't enforce developers to do the same thing. So developers could do something by themselves, because there is no security policies in a company. So there's no culture. So I think that the things that the biggest thing that need to change is around the company. For the company, this aspect is very important. The company will enforce this best practice. Otherwise, because when developers when they get projects, they get some time. Okay, they get some schedules. If security is not in this project, if the time is not given for implementing secure coding, so they will not take that time to implement this or to store a password securely, because there is no time. So as long as the business logic is implemented as was required, so security is just ignored. I think that the main point is that, so it's not because I only mentioned that or because I come from engineering background. I have read a lot, some books from Bruce Chestnut, who says the same thing in all his books. The biggest problem in security is because for companies, these things are not important. So they're not going to invest money on these things. That is the point that I wanted to mention. Maybe the problem is there. The biggest problem is there, and the explanation why developers don't store passwords securely, even though they know how to do it, or they could look for techniques to do it. They don't do it because they don't have the time to do that, or because for the company it's not that important. Anyway, they will be paid if they do or not. That's the point.
So I think there's definitely a side to that. We need to incentivize security. I like legislation. If you're going to do security, you should show you're at least trying to follow these things. But I think there's something more than that here, right? It's all very well having a company where you don't care whether you get paid or not to do security, or our developers seem to think they were following best practice. They seem to think, oh, this is the right way to do it. Now, whether that's because they were last in school 10 years ago and our standards for password hashing have moved on, or other tasks, could be one side of it. And actually now their knowledge is out of date and we need to try and make sure they're following best practice. I think it's more than just, who cares about security? I think there's something here about lack of, I think there's something here about the developers think they're getting it right. And despite all these breaches, despite us saying, look, this is really tricky, they're going, well, I know that, I get it right. I don't get breached that often. I think there's also that factor into it. I don't think it's just as simple as the organizational culture as well. I think there's something more here about developers not being confused as to why what they're doing currently isn't right. Anyway. Any more?
Right, not anymore in the charts, but I have a few questions.
Different.
So yeah, so the first question is actually I guess rephrase what Percy just said. It's really, I guess, for the developers, they have no incentive to do the things right or secure because they don't get paid for writing security, for more secure code. Actually, they might get less productive if they try to make the code more secure, and then that is not in their interest. And if the password database gets breached, they won't get punished, right? Because no one will blame them afterwards, and it might not get breached at all. So for them, the best strategy is just write whatever and then satisfy the minimal requirements the company sets, and then that's all.
So I think we have to be really careful here.
Mm-hmm.
So there's, in user-centered security, we have this wonderful idea of, users are not the enemy, right? No one goes into something going, I want to be insecure. I don't care about, I'm going to put my password on a post-it note because, that makes me feel happy. And I'm going to have a password, which is password 1, because that's what they've told me not to do. People like to try and do the right thing. I think there's really have to be careful that we're not blaming developers,
Mm-hmm.
That's back to us, and starts telling us, why didn't you learn from what we were saying, when she was saying it? It's more than it's just, can't developers just do this task better? Why can't they just care about security? We have to find ways to help them.
Yes, right. I'm not blaming them. What I'm saying is human nature, right? It's human like to being lazy.
Humans like to be lazy, but they also like to do programming, right? People program in Haskell, voluntarily, and there they have to do all this extra work to make the types line up. Why are they doing that? Well, because it's good. I don't think it can be purely attributed to laziness. There may be an effect of it there, but let's test to see if laziness really is.
Yeah, I guess we have different views on whether we should trust developers or not.
I used to be a developer, or still am. I don't think anyone. I think we have to trust people to take pride in their work. Because if people don't have pride in the work, then at the end of the day, what we're doing here is all for now. If no one genuinely cares whether they do it well or not, nothing we're ever going to do is ever going to make any difference.
Yeah, that's
I have to have some hope that we can make a difference, that people do care.
Yeah, that's true. But another thing is we can't just rely on people themselves to do things right. We have to have other ways, for example, auditing, for example, accountability,
Absolutely.
for example, penalties or rewards, those kind of things to let them do things right. Because sometimes it's just right. Maybe 90% of the people are good people, but still there are 10% maybe.
If I can get 90% of my people storing correctly, I will frankly stick my hands up and say, job's done, someone else can deal with this problem.
Yeah.
Yes, if we can get 90% of people programming securely, but we're not at 90% of people securely to begin with.
Yeah.
I will deal with the remaining 10% once we've dealt with the current 90%.
Yeah. So another thing I'm thinking is, in your study, you notice many of the programmers actually write their own code for storing passwords. Did you make it clear that they can actually use APIs? Because if I'm doing this, maybe it seems to me, right, like I'm cheating if I just use API, one line of code, and then complete this task.
Oh no, several people just gave us one line of code. We didn't have anyone use a framework. Yes, we said you can Google for it, we can search, use whatever thing you want. We found people just did it straight off. I think there'll be something interesting there, doing something with a smaller number of participants, going really into detail as to why they're doing it. Their programming exercises here. I'm actually really analyzing why people are doing these things. We went for a quick test of numbers. I think that the other one would give you much more interesting and better rationales.
Okay, right. Okay.
Joe, are you planning a follow-up study?
Not at the moment. We've got other questions we're interested in. But I'd be really interested if anyone else is doing it. Please shout at me. I'd really happy to talk to you.
Percy has something in the chat. He would like to add something.
Right. Yeah. So let's see ask first, and then Percy.
Okay, hello, thank you for giving me one more opportunity to mention something. I've been working as a database administration for 15 years now. So in my experience, I have seen that most developers don't implement secure code because they just don't have the time to do that. I just want to emphasize on that. When I ask them, why don't do you implement more secure code, or at least one the simple methods to secure your code? They say, okay, because we don't have time. It's quicker. Okay, it's quicker to not to do it. It's quicker because we are paid to implement the business logic and to make the system work as fast as possible. So they just don't do that. Don't write secure code because they don't have the time. They're not given the time. So that's one point. But I'm not blaming developers when I say this. I just sharing with you the answers they told me in that moment from their experiences working for those companies. And that's what the point I want to make again. If companies, the security is not the main point, but the most important thing, they are not going to give their developers the time to implement secure code. As simple as that.
And I think there has to be incentivization for companies to, get this right.
I'm not blaming. I'm not blaming.
No, I completely get it.
I'm not blaming. I'm not blaming developers because if they want to implement secure code, they will have to invest more time, spend more time on that. And for the directors or managers,
if it's a choice between getting the job done or getting it done,
that part is not tangible. It's not in the project. So in the project, it's not included to implement secure code. It's many things is all about money. If money is not for to implement secure code, so they will say, the manager will say, developer, okay, I'm not paying for it. The time to implement secure code is not in the project. You have to stick to the project. Doesn't matter anything else. You have to stick in the project. So it's just as simple as that. I think that's the main things that if we want this situation to change radically, I think there is something to blame with the companies.
Yes,
the company needs to be more aware about these situations, and it makes security top priority. With that, I think a lot of things will change automatically. That's the point I would like to make.
So I think there's something here, absolutely, right? If a company is not going to have an interest in doing securely, and you're going to get fired if you spend 10 times making your code is secure instead of getting 10 times as many bugs cleared, we're never going to have security in organizations. It's interesting that we've got approaches, things like, for the IT sector, I guess more cyber essentials, where actually you are being incentivized to have a nice big ticky badge saying, look, we've checked your code and it's good, and it's a nice thing from a regulatory insurance point of view.
That's right. We could.
I think it's a good thing. But
for example, we could have the best cryptography technique ever and ever, but it doesn't matter. For security, it's not that important. If secure policies are not implemented correctly, it doesn't matter, because the password that is used by the cipher could be in plain text anywhere else in the company. So it doesn't matter if you are using the best cryptography technique if the password is just there in plain text.
So I think this is why having this stuff baked into the language is so important, right? PHP, it's a one-line function, right? It's just password hash. That's it. Not a case of, do you need to spend more time than it? In fact, doing anything less than that is going to be more time. I really think getting it in and getting developers knowing that these features are there is so important.
It's so important, but to achieve that, I think companies should implement the security policies and educate the developers a bit more, or give more resources, more time.
I think
and make developers feel that they are paid to implement secure code.
I think we have to do that, but again, we have to understand that developers aren't always educated in this, and that there is a big cultural shift against it, right? We have not been doing secure code for a very long time. It's going to be more than just flipping a switch. We need approaches to help developers get to that stage, rather than just saying, well, we asked you, we incentivize you to do it securely, why aren't you doing it now? Anyway, I see CMAX had his hand up for a while, and so shall I let you get in?
Yeah, thanks. I mean, I wholeheartedly agree with what you were saying, but if I'm I'm trying to find a sort of a glimmer of hope somewhere, right? So I've been telling myself, maybe if you're looking for good developers, they're not unprolific. They are being paid by some company rather than spending some time on prolific. Do we know sort of more about the demographics that participated in your study?
So I would agree. A lot of the developers on prolific, some of them, yes, they're saying they have lots of experience. A lot of them were very evidently students or undergrads. Some people got very sulky. They said, because we asked people to identify as programmers, and people, when we said, well, I have no programming experience and I don't know how to write code. Okay, why are you doing the study then? Obviously, those people we rejected from the study. Actually, is the demographic okay? There has been a bit of work, again, by Matt Smith's group out in Bonn, that has done studies with engineers paid £100 an hour, with students with these prolific surveys, and they have found that actually they are all statistically equivalent, which is hopeful. My feeling for it, this was my first time doing something with one of these survey tools. My feeling is you're going to get an awful lot less experienced developers, and there is an incentivization to getting the task done as quickly as possible, right? As many servers as you do, the more money you get. I think we get okay results out of them. I personally would like a little bit more detail, but you get numbers.
Sure.
Nice thing.
I mean, the incentivization to do the task as quickly as possible is actually in line with pressure at the time of if you have a job, right? So I guess that's not a big issue, sort of simulating that pressure that you have if you have a job, right? But yeah, okay, I see what you mean. Okay, cool.
And again, other studies have been done with developers recruited from companies, and they've all seen similar things.
I see. Okay, so their results are bleak as well. All right, there's no hope.
Well, we will get people programming securely one day.
Yeah, hopefully.
Any more? No worries.
Okay, Roy, another question.
Yeah, I just wanted to say a couple of things. One of them is that, I mean, it was just mentioned that you got these people from prolific, and they're all self-selected respondents, right? So this is very often a methodological problem in various kinds of studies. Second thing about incentives, right? So something that Chung Yu said made me think about this. One of the things that one could do in a study like yours is to mention something about quality and scoring and whatever, right? And just say, the higher your score is, the more money we're going to pay you, right? That might change the incentive equation a little bit. And then the third thing that I wanted to say is that, again, inspired by something Chung Yi said, there's very often not much of a penalty for screwing up. And one of the things that you can point to for that is the proliferation of methodologically unsound papers in the literature. I mean, they're just all over the place. And I think there's two reasons for that. One of them is researchers are not very acquainted with with good rigorous research methods. And the second problem is that neither are the reviewers, right? So nobody really gives a rip about it, and all this stuff gets published, and it's just a colossal waste of resources. Anyway, that's all.
Actually, with software engineering, Paul Ralph has done a fantastic job with ICSE trying to push a little bit more rigorous methods onto computer scientists, because we are a young science, right? We grew out of the the workshops surrounding physics and maths, right?
I'm not buying it. I just don't buy it, right? Young doesn't mean that you can't read,
no,
right? And there's methods
been,
all over the place. One can read.
We can read, and as I have shown in this study, developers really don't read standards. What hope have we got with statistics books? Yeah, I
don't even read blogs. So.
Joe, can you say again that the group that you just mentioned, who's pushing rigor?
Paul Ralph and ICSE. So he's been there is a proper name for it, but there's a ACM or IEEE working group for it, and they pushed a load of guidance out for computer science students, and I can't remember the name of them at the moment, but if you search Paul Ralph working group,
is it poor? Are you saying Poor Ralph?
Paul Ralph, PAULRALPH. There have been people pushing, these are the tests. If you want to do qualitative study, these are the things that you need to include. These are the things that you need to consider. We are getting, better, as a field at, expecting things when we're doing coding for kappas to be quoted, having some idea of reliability. The odd effect size is always nice. Yeah, we're getting better, but we're still, yeah, I know other scientists sometimes laugh at computer scientists for our statistical rigor.
Where is this? Where is this guy, Paul Ralph? I've just Googled it.
Can't remember.
Okay. Maybe somebody else can fill me in here.
Okay, let me ask. Any other questions? Okay, if not, let me stop recording.